For computers that think, rather than just do, technology is evolving. Let's look at the evolution of computing in order to prepare for the next paradigm shift. We will look at the evolution, from sequential processing, to parallel processing, to the next phase, where the focus is on collective processing of information. When you have to deal with the real world, you have to deal with multiple issues at the same time. Each issue has its own set of tactics and strategies that can be employed. Each issue will have its own risks and rewards. Some issues will share the same influencing factors, but may be interpreted differently. Some issues will have unique influencing factors. All issues will need to be considered collectively, because they are all competing for limited resources. And at the same time the issues will be changing in importance because their influencing factors are changing. They can be reprioritized, but they cannot be ignored. For each issue, you will be considering what, when, where, how, who, how much, how many. You will be considering new threats, new opportunities, who will win, and who will lose with your decisions and actions. You will be considering secondary impacts, collateral damage and long-term effects. And you will be relying on machines to deliver the decisions and actions. So let's look at where we started with sequential processing of information. With sequential processing you have a central processing unit, or CPU, with an instruction pointer that steps through a series of instructions that load and manipulate information from memory. The digital CPU processes binary information by sequentially processing if-then-else instructions to manipulate the instruction pointer. This is what computers have been doing for years. Demands for more and more processing pushed for reduced cycle times, that, in turn, increased heat dissipation. This drove the development of parallel processing. With parallel processing, multiple CPU cores are used. Programs were broken into parts that could be processed in parallel. And what do you end up with parallel processing? Well, you have multiple CPU cores, each with its own instruction pointer, stepping sequentially through its encoded instructions, processing the same old if-then-else logic. It's just that you have multiple CPUs doing the same thing that computers have been doing for years. Continuing with our evolutionary story, we have an evolutionary objective. Rather than using computers as machines that can process information to solve specific, contained and isolated problems, we are looking to produce machines that can deliver expertise on their own. In that same vein, machines can begin to pursue goals with, or without human assistance. When humans dispense expertise, expert decisions, or expert operational control, they are using their judgment and reasoning skills to deliver that expertise. It is the human's ability to use judgment and reasoning that has separated humans from computerized systems in the past. Judgment and reasoning is what allows the human to consider multiple problems at the same time. The human's judgment and reasoning skills accept influencing factors from many sources that are captured through the human's own biological sensors, which collect information from a wide variety of sources. The human expert understands how to value the influencing factors as well as the many competing issues, such as survival, comfort, assigned tasks, planning for the future, and so forth. When a human delivers behavior, expert or otherwise, the human is weighing the importance of objectives and influencing factors and balancing alternatives. This requires the collective processing of information. This might be described as the process of observing and loading information, followed by a consideration phase, that eventually results in a decision or action. The consideration phase is where everything happens. The loaded influencing factors are integrated, and the results propagate through a web of interrelationships. The system attempts to stabilize. If a balanced solution is determined, the cycle exits. If not, the process loop runs again. In an analog computer, Like the human brain, the electrical signals between neurons are balanced to make subjective, value-based decisions. For collective processing of information on a digital computer, a cognitive cycle iterates until a stable solution is achieved. This is the domain of CompSIM's knowledge-enhanced electronic logic, or KEEL technology. With KEEL technology, a set of tools makes it easy to create KEEL cognitive engines that provide the collective processing of information necessary for machines to execute judgment and reasoning skills for adaptive command and control. This enables software applications, or machines, to deliver expertise and pursue human-directed goals on their own. And unlike humans, decisions and actions controlled by KEEL cognitive engines are 100% or explainable and auditable. While humans may be unable, or reluctant, to explain their behavior, decisions and actions directed by KEEL cognitive engines are delivered with mathematical precision, exposing the embedded value system behind everything they control. So with the objective of mass-producing the delivery of expert behavior, having solutions that are auditable and explainable is necessary, as is the ability to rapidly fix any problems that might be detected.